Hello everyone. So today we will go with DBMS, which I have written by my hands. So see, so first DBMS. So DBMS refers DBMS or database. So database refers to the unstructured as well as structured data. Unstructured data consists of 90% of data in the world, like web pages, etc., etc. And structured data can be considered like IRCTC website data, university website data, and other relational database management system. Like it is in table format, tabular format. So as we see that the IRCT website shows the timetable of the train in the tabular form, the time given, then the train number, then all the relational data. So that's why it is called as structured data. Now DBMS versus file system. So in DBMS, DBMS comes after the disadvantages which are not good in the world. So DBMS comes as a improvement of file system, as a future product of file system. So considering the pros and cons, we consider as file system like for 1 KB, we like file system can be considered as like the hard disk type. So for 1 KB storage also we require 25 GB setup. But as there are no 1 KB setup devices, so we are requiring 25 GB setup, and this results into a lot of memory loss or lot of memory wastage. Then searching is easy in DBMS, as we have seen in the previous video that DBMS refers to the DBMS can be considered as the database management system. It can be defined as 1 minute. We will define DBMS. So DBMS is a software. Uh, DBMS is a software used to store and retrieve user data while considering appropriate security measures. It is a software for storing and retrieving the user data while considering appropriate measures. It consists of a group of programs. This is nonsense. So DBMS accept the request for the data from an application and instruct the operating system to provide the specific data. In last session, DBMS helps user. This is also nonsense. So main point is DBMS is a software. It is a software for storing and retrieving user data while considering appropriate measures. So this is definition of DBMS can be considered like it is a software used for storing and retrieving user data considering the user security measure, appropriate security measures. Then DBMS, then comes the database. Database can be considered as organized collection of data, organized collection of structured information data typically stored electronically in a computer system. So here the Striver has given us the definition. It is an organized collection of structured information. Organized collection of structured information or data typically stored electronically. Organized, what is that? Is the organized collection of structured information. Then database is usually controlled by the database management system. So the together data and the database, together data and DBMS along with the application that are associated with them are referred to as database system. This is also an important line, like together data and DBMS along with the application that are associated with them are referred to as database system. Okay, this one was main point, and third was database system. So database system is same as data and the DBMS together with the application they provided to us is known as database system. And database is a structured. It is organized collection of structured information data which is typically stored in the electronic system. Now again come to our site our slides. So these are the main part of database management system. Then for advantages and disadvantages of database management system. Advantages advantages of database management system are so many. Like it improves the security of the data. It also work as a remote. It means database can be accessible from any remote location. It reduces the data redundancy, like data duplication. Unique data is stored in the DBMS. Then it reduces the uh, memory wastage. Then concurrency, that is concurrency problem will also get solved due to the database management system, as a lot of user can access the data at the same time. Then it improve data sharing, better data sharing and data integration are the main two important parts. Data integration and data sharing. Then it reduces the inconsistency and improve the decision making, as all data are in this like tabular form. It is in a structured format. We can easily take the decision based on the output or based on the data we have, as it is in the structured format. And it improves the data end user productivity. Again come to our slide. Now there are two types of database management system. First is two-tier system, which is used in the older age, and now it is replaced by three-tier architecture. Three-tier architecture is more advantageous than two-tier architecture. Now considering the two-tier architecture, it consists of two layers. One is client and other is server. So it is also called as client server architecture. The client the client layer consists of the user like us, which directly access the database when the present in the database server. So it is like anyone can access it and anyone has the right to change the database server. So it can create a lot of problem. So can create a lot of problem, and that's why its advantages are so less as compared to the disadvantages. The more main advantage of it is we can easily maintain the data and limited database, and it is good for limited database only. Now considering the disadvantage part, it has so many. When we consider large amount of database server database when we consider large amount of user, it can create a problem. So scalability could be a major cause. Also, it increases the security problems, as anyone can access it and anyone can change it. No one can be like as faithful as no one as we can't be as no one. No, 1 minute. Security. So in case of security, we can't assure that he or she will not do any malpractices in the data. So security is the major concern. Yes, and now coming to the third tier architecture, it is called a third tier because it consists of three layers of architecture, three layers. So first is the client layer, second is the application or we call it as the business layer, and third is the data server or database server. So in this third three tier architecture, the main difference is the layer which is present between the client and server layer. It is called as application layer. So client can access the data with the help of application server. So application has given some right to some user only to make any changes in the data layer or server. Anyone can't change the layer. Anyone can't change the data present in the server. The main difference is that only. Though anyone can access the data, but no one has the right to change or edit the data, and this makes it more advantageous. Like its main advantage is its security, its scalability. Anyone can access it, and anyone has the right to ask for permission or ask for any request. Anyone can request the data easily, and it helps in scalability. Its main problem is its maintenance. Its maintenance is quite tough as compared to the two tier architecture. But considering the security and scalability, three tier architecture is more beneficial. Now, if we want to give real life example, consider a ticket counter present at the railway station. We are client, we go to the ticket counter, and the person who is sitting inside the ticket counter, that other side of the ticket counter, he directly take the like, he directly change the data present in the server and directly issue us the ticket. So it is a two-way architecture. He have all the right, so he can directly edit and give us the ticket. But for the three-tier architecture, we can consider like online ticket booking system. Here we have to access the website. So for accessing the website, we have to generate our authentication process. We have to go through authentication process. So through authentication process, it acts as an application layer. Anyone can't log in. Anyone can't just go and claim the ticket. Everyone has to log in their data, log in their ID, and then only he will get the ticket issue. He will get the ticket issue after doing certain amount of process. Certain process. So this makes it more beneficial. Now, schema in database. Logical representation of database. It can be single table or multiple table. This is nonsense. Now, three schema architecture are. Now this comes the three layers of data abstraction. So mainly there are three layers of data abstraction. One is physical layer, which is present internal inside the server, like we can consider as hardware part. Then comes the logical part, where concept or logic are designed and made, and third is the external part, which can be considered as view layer. So in the view layer, any person has the right to only view the database, not do any kind of modification in the database. So these three layers of data abstraction, which make it more useful and more secure. Now physical, this is all consider physical layer is accessible by the database administrator only. Conceptual layer can be considered as a table relationship, why the table is related to the another table, and external schema can be considered as us. So considering a real life example, we student, faculty, and like HOD, it can be considered on the same view layer. The conceptual or logical layer can be considered as can be is present in the in the conceptual or logical layer. We have only few members like the DB administrator or someone like that, and the third, which is database, which is present in the hard disks present in particular room. So all the and the access to that room is also with the DB administrator. Now there are many types of key is just like a solution key can be considered as just an attribute. It is an attribute through which we can access the data. So use of key is to uniquely identify any tuple in a database. Now collection of there are many types of key. First one here is written as candidate key. Candidate key can be considered as collection of more than one primary key, or collection of 2 or 3 columns to which can uniquely identify the database. So here we can consider as Aadhaar card, voter ID, license number, and now collecting all the columns, like considering all the columns together, we can give it as another key, and that key can be said as candidate key. Then again is the primary key. It is a primary key is the unique and not null key which can help us to uniquely identify the database, and it is only one. There is only one primary key present in all the table. Okay. Then next is the foreign key. Now foreign key is the kind of attribute that refers to primary key of the same table or another table. For example, there is 2 tables, so the primary key of one table can be considered as the foreign key for another table, so that both the table can be interconnected. Okay, that's it. Now, to maintain the referential integrity, there are three main things. Like if we done any changes in first table and whose data is which is linked to the another table through the primary key, through the foreign key, then there can be three major referential integrity problems can be occur. First one is the insertion referential integrity. The second is deletion referential integrity, and third is updation referential integrity. Now, insertion during insertion of insertion reference table. And okay, so first of all, this is called as reference table. We have the primary key is this, and the primary key which acts as the foreign key for other table is called as referencing table. So reference table will not cause any violation if we insert a new table, if we insert new tuple, but referencing table may cause violation. Now the major are deletion and updation. Insertion is just a third case. It can't cause any problem. Like if we insert a new tuple in the first table, it couldn't cause any error in the second table, as it doesn't have the same key in the second table. Deletion may cause. Now if we deleted the data from first table, which is main table, and the same key was present in the referencing table, now the data is deleted from first main table, and still the data is present on the like its referencing table. So this can cause a problem. So for this we generally use on delete cascade or on delete set null. So it will either delete both entries, or it will just delete the entry from the first main table and set the entity in the second table as null. Set all the entities present in the set all the column set all value present in the second column as null. Then same for update. Updation can cause both problem. Here we have to consider the case for 1 minute. Okay, so here we have one on delete. Here on delete cascade. What will happen if parent table is deleted? Parent table is delete. Okay, here on delete null and on delete set null. On update cascade. So on update cascade can be added to the table while creating constraint. Suppose there is a situation we have 2 tables, so the primary key of one table is the foreign key for another table. Now if you want to update the primary key of the first table, then using on update cascade, foreign key of the second table get automatically updated. Now this is the most important part. What I wanted to understand you, convey you. What I wanted to convey you. This was the part. Like it can be like on update cascade can be added to the table while creating constraint. So what it will create is that if I update the value of primary key in main table, so if I had written a constraint, if I had written on update cascade during constraint, then it will automatically update the primary value in the next table also. Primary key value, which is foreign key for the other table, and its value will also get updated. Okay. Then coming back to our notes, this is about foreign key. Then this is all. Then super key. Super key can be considered as a combination of all possible attributes. Super key can be considered as all possible attributes which can uniquely identify the 2 tuples in a table. Like super key is the superset of a candidate key. Like it consists of all the possible attributes which can uniquely identify the tuple. Just one line. All possible attributes which can uniquely identify the tuple. All possible attributes which can uniquely identify the tuple. Okay, and here what I'd say, superset of any candidate key is a super key. Okay, done. Now ER model is entity relationship model. Uh, Now entity can be shown with a rectangle or square shape. Then attribute type can be shown in the circular or oval shape, and relationship is shown in the diamond shape or rhombus shape. Once again, I will repeat. Entity relationship model is there. So entity, attribute, and relationship are the three major parts of the entity relationship model. Entity is shown by a rectangle or square entity. Then attribute is shown in a circular or oval, and relationship is given. Relationship can be denoted by rhombus or kite. So types of attribute, there are 5 to 6 attributes. Types of attribute are there, like single versus multi-value attribute, then simple versus composite attribute, then stored versus distributed attribute, stored versus derived attribute, stored versus derived attribute, stored versus derived attribute, key versus non-key attribute. Stored versus derived attribute, key versus non-key attribute, and then again required versus optional attribute, then complex. These are all nonsense. Not going to ask much about this in the interview. Okay, the types of attribute: single versus multiple attribute, multi-valued. So single attribute, for example, is, consider this diagram which I have drawn here. So student can be considered as the entity. So it has so many attributes. Attributes, as I earlier explained, it is shown in the circular or oval shape. So it can have many attributes. It can have many attributes. So first is registration number, which is unique. So we have just underline it as key versus non-key attribute. So unique key attribute is always denoted by underlining it. Unique key attribute is always shown using the dash under its, using the always. Okay, so unique attribute is always denoted using underline. Okay, done. Then again comes the age. Age is also age here is a simple attribute, as it is of one type. But now I will tell you one by one. Okay, I will tell you one by one. Single versus multi-value attribute. Single means only one value, and multi-value means it can have multiple values. Like single can be registration number can be single, and multiple attribute can be a name. Student name can be considered as first name, second name, and first name, middle name, and last name. So it is a multi-value attribute. Now second is the simple versus composite. Simple can be considered as age. It is a simple. It is not composite. It does not come. It does not come. It is not a combination of more than one attribute. Okay, multi-value attribute. Sorry, I forgot to mention. Multi-value attribute is only mobile number, as mobile number can be vary from person to person, and one person can have multiple mobile numbers. So it is a mobile number, and student name can be considered as composite attribute. Stored and derived. So stored can be considered as age. Age is not a stored. It is a derived. Age can be derived from the date of birth, and stored is a date of birth. Date of birth is stored. It can't be changed, as date of birth is always only and only one. So these are the some types of attribute. Then there is a degree of relationship. Degree of relationship can be considered as cardinality. So cardinality definition, if anyone asks you about cardinality, so cardinality is the numerical relationship between rows of one table and another table, rows of another table, rows of one table and another table. Okay. So there are four types of cardinalities, or four degrees of relationship: one-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. So one-to-one given below a table or ER diagram. Employee works for a department. So here one-to-one relationship occurs. Like employee will work for one department only, and department of that depart one-to-one. Employee will work for that department, and like consider both table one to one. If we take EIT employee, one employee will work for only one department. So this is one to one. Don't go in depth of that. Now comes the functional dependency. X is dependent on Y. So here X is a determinant attribute, Y is dependent attribute. X determines Y. So X is a determinant, Y is a dependent. Right? X is a determinant, Y is a dependent. Y is dependent on X. Y is determined by X. Okay. So here only one property is correct. One or two more properties are important. First is reflexivity. Now, if Y is a subset of X, then X determines Y. If Y is a subset of X, Y is a subset of X. Like X is some set and Y is some small part of X. Then X will determine Y. Now, second is transitivity. Transitivity. If X determines Y, then Y determines Z. then X should determine Z. X should determine Z. Transitivity is Z. Decomposition, if X determines Y, Z, then X determines Y and X determines Z is necessary. But it is not valid. Like XY determines Z. If XY determines Z, then X will determine Z or Y. It is not valid. Now comes the normal form. So I will tell this normal forms in next slide. I have clearly explained there. Here there can be confusion. Here we can have some confusion. So I will explain that part in the latter part of this video. Okay. So lossless or lossless joint decomposition, it is very less important part, but we can go with it. Common attribute should be candidate key or super key, and of either no. Let it be. So there are, uh, as we have talked in the previous video about the four main data like DBMS languages: DDL, DML, DCL, TCL. So these are same here. DDL will design or define the schema. DML will manipulate the data in the table. DCL will control and access and request the data, and TCL will control the transaction. It will control or manage. This TCL will manage transaction. For TCL we have commit and rollback. For DCL we have grant and access, grant and revoke. For DML we have insert, update, delete. For DDL we have create, alter, drop, truncate. Okay, so here concurrency control protocol are two types of protocol: timestamp based protocol, lock based protocol. Timestamp based protocol refers to the order the transaction based on the timestamp, and lock based protocol are can be further divided into 2PL, strict PL, simplistic, and pre-claiming. 2PL refers to the two-phase locking. Strict PL refers to the strict phase locking. And simplistic and pre-claiming are not much important. We will discuss in later. Now scaling. Scaling means increasing or decreasing the capacity of increasing or decreasing the capacity of a system, increasing or decreasing the capacity of a system based on our requirement. So vertical scaling and horizontal scaling are two parts of it. In vertical scaling, generally we refer horizontal scaling. I will tell you why we refer horizontal scaling, but we will go with vertical and we will define vertical and horizontal first. Vertical scaling is used to increase the capacity of system single machine. Vertical scaling is used to increase the capacity of single machine by adding some external components, like adding vertical scaling. Okay, so vertical scaling is used to increase the capacity of single machine. Vertical scaling is used to increase the capacity of single machine by adding some external components, like adding graphics card, adding extra RAM to the CPU or to the machine, extra RAM to the machine. And horizontal scaling means adding more instances of machine, like adding extra machine as it is. So vertical scaling and horizontal scaling can be summarized as: vertical scaling will be buy bigger machines, and horizontal scaling will be buy more machines. Now, while buying bigger machines, consistent data will be consistent, and while buying more machine, data can be inconsistent, as there is loss while linking two machines. So data inconsistency can occur during horizontal machine, but horizontal scaling is good as the horizontal scaling is good as the user increases. Like as user increases, vertical scaling is not good as it uh, vertical scaling is not good while considering vertical scaling is not good if we increase the user at large amount. If the user quantity get increased to a large scale, user get increased to a large amount, as we have hardware limitation, so we can't increase we can buy more like bigger machines. So horizontal scaling is the best when the user increases. Now sharding is a method of splitting and storing single logical data set in multiple data. Sharding is splitting of Sharding means there is one data set. We have to store this data set by splitting it and storing it, splitting it and storing a single logical data set in multiple databases. Storing single logical data set like splitting and store it in a multiple database. By distributing data among multiple machines, a cluster of database system can store larger data set. By distributing data among multiple machines, a cluster of database system can store large data set. Okay. So storing data records across multiple machines, and this method has approach to meeting demands of data growth. So sharding can be considered as splitting and storing a single data set into multiple data set, single logical data set into multiple database. So by distributing data among multiple machines, a cluster of database system can store large data set. So by distributing data among various machines, a cluster of database can store large data set and handle additional requests. It allows the database cluster to scale along with the data and growth. It allows the database cluster. Sharding will allow the database cluster to like scale as the as to scale along with growth, to scale along with its data and traffic growth. Now storing data across multiple machines, this method can approach to meeting demands. So necessary. Memory can't be large enough when active data set. Memory can't be large enough when active data set is big. So local disk is not big enough. Vertical scaling is too expensive, and that's why we. So here come the last and final parts, which I want to tell you. First normal form. There are 5 normal. Mainly there are 4, but it is mainly there are only most important are only 4, and there are various normal forms other than that. So considering the first normal form, now as you can see here, first normal form is the basic normal form. It does not contain no multi-value. Is first point is no multi-value attribute. Like it shouldn't contain multi-value attribute. Multi-value attribute like mobile number or languages, which one person can speak many, which one person can have more like 2 or 3 mobile numbers. First point is that no multi-value attribute in first normal form. Second one is only single value like same. And third is every attribute must be atomic. Every attribute must be atomic. Like it should be unique. It should not be like same. It should not be like repetitive. So if we consider the table, so one student can know C and one student can know same student can know C++. So C and C++ can be written in another tuple. We cannot write it in the same row as the language can be a multi-value attribute. So now in second normal form, the condition should be it should be in the first normal form, and there should not be any partial dependency, only full dependency. Partial dependency, by saying partial dependency, I mean to say like if AB is dependent on C, then B is dependent on C, or A is dependent on C is a partial dependency, which is not allowed here. If AB is dependent on C, then whole AB should determine C. AB determines C. There should not be like A depends on A determines C or B determines C. Partial dependency not allowed. Now in third normal form, it should be in the second normal form. And second point is there should not be any transitive dependency. Transitive dependency means if X determines Y determines Z, then it means that X should determine Z. So this should not be the case. No non-prime attribute should determine non-prime. If X determines Y determines Z, Y should not determine Z. As it is mentioned, no non-prime attribute. No non-prime attribute should determine non-prime attribute. If X determines Y, it means Y is a non-prime attribute and it should not determine any other non-prime attribute. Now in BCNF, it is a voice called normal form. It is derived from the third normal form only. So third normal form, it should be in third normal form. And the next point should be left hand side must be a candidate key or super key. Left hand side must be a candidate key or super key for all dependency. For all dependency, left hand side must be a candidate key or super key. It must be a candidate key or super key. Then comes the schedule. Schedule can be considered as chronological sequence, chronological execution sequence, chronological sequence of multiple transactions. We can say that chronological sequence of multiple transactions or chronological execution of multiple transactions. Chronological execution of multiple transactions. So there is two types: serial schedule as well as parallel schedule. Serial schedule is consistent. Like we can consider it as first process will start and it will over. Then second process will start and second process will terminate, and then third process will start. And in case of parallel schedule, the case will be like first process will start, second process will start in between, first process will end at some amount, and then second process will end. And this will be taken place at a parallel time. Like there is no gap between the starting time. There is no gap between there should not be any gap between end time of first and start time of second. So it advantages and it has its advantages and disadvantages. Main advantages of serial schedule is it is consistent as one after process is happening, but in case of parallel it is sometimes inconsistent. There can be a loss. Then serial schedule is more time consuming as transaction may take large amount of time due to the due to the due to the due to the options like concurrent, due to the cases like deadlock. And in case of parallel, it is a time efficient. It will perform. It will increase our. It will improve our performance. It is time efficient. Serial schedule queue in ATM. No two people will transact at same time. But in case of parallel online banking, we can transact at same time, no matter how many people are there in the queue. Next is dirty read. Dirty read can be considered as like first transaction is going on, second transaction is going on. First transaction, he read data, he write data, and second transaction then started and he read data and he write data. But due to the some complication, first transaction get failed after writing of the second transaction, after writing, or we can say committing the second transaction. So this can be, there can be a irregularity or there can be a mismatching of data in the server, in the database. This can be considered as dirty read. You can consider as example as IRCTC. So if two person and in online booking start, one person started earlier and it goes until the transaction page, like he booked the ticket and goes to the transaction page, but his transaction get failed, and when he was doing the process, another person logged in and he tried to fetch the data and he sees that the seat is already booked. So he tried to book another seat, as he sees that there is only one seat remaining. There is okay. So okay, for example, I and my friend want to go to the trip to Goa, and another person who wants to go to Goa in the same train, and there are only two tickets remaining in the train. So if that person comes earlier and he logged in and he was completing his process and adding and putting his all his details, personal details, and he goes to till transaction page. Now I log in the site while he was processing, he was inserting his personal details. I logged in and I see that there is only one seat remaining in the train. So I will go and I will book that one seat for me or my friend, and after login I will make transaction. But if the person who is doing transaction got, like he got some failure message due to some any consequence, due to due to any reason, due to due to any, for example, he got his transaction get failed due to some reasons, and I come to know, as I was booking I was able to see only one seat. I booked that seat. I was able to see one seat, so didn't book it, as I was requiring two seats. And after his transaction get failed, I and before his he okay, let's take for this third take. Two persons, me and one another unknown person, tries to book one seat present in the same train, and the train has only one seat remaining. So firstly he goes and try to book the seat, and as he was putting his personal detail, I log in through my user details, and uh, I come to see that the train is full, like there is no seat available. And after a certain period, the person who unknown person who is doing his booking got some transaction failure due to some reason, and he was unable to book the ticket. And now I can see that I was also not able to book the ticket, and he was also not able to book the ticket. So this will cause the major problem, and this case is called as dirty read. Now read write conflict or unrepeated read. This is the, like, read write is the main conflict which is present. Read write, write read. Read is not a conflict. Read can be acceptable, but read write is not acceptable. Now nth highest salary. So to determine the nth highest salary, you have to take ID salary from the employee E1, like from the employee table E1, where n minus 1. N minus 1 means nth highest. We want nth highest, so we will have to n minus 1 people's n minus 1, because n minus 1 people are below that salary. So it will give us, like, n minus 1, we are taking n minus 1 because n minus 1 people are below his salary. So the next part of query will give us the value n minus 1, like it will give us the count of people which are present below his salary. We are writing the query such that the count the count will be such that it is number of people present below his salary, and his salary will be nth highest. Now select count distinct salary for unique salary from employee E2, where employee E1 dot salary is greater than E1 dot salary is less than E2 dot salary. So E1 dot salary here, same table, E2 dot salary. E2 dot salary, why we are taking E2 dot salary? Because it will give us the count of employees, from E2 table. So it will give the count from E2 table, that E2, the salary of employee from E2 table. We will just take one salary from E1 table and it will match all the salary from E2 table. Now if it match more than, like, if it match, like, if it match n minus 1 people, so E1 salary will be the highest, nth highest, right? N minus 1 highest, so it will be the, okay, that's it. I will resume my session tomorrow. Thanks.